FSA Quiz 5. Number 1. What is the distance between the points -7, 1 and -7, -7 on the coordinate plane? Well, I'm going to show you a method that I would like you to use, and then we'll explain why this method works thereafter. Let's first identify the x's and the y's. We'll identify the y's with blue and the x's with red. Let's start with the x's. In the alphabet, if you recite it, it's A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W, X, Y, Z. X's always come first. So let's identify the X's first. Let's rewrite this. -7, 1, and -7, -5, just so I can have some space to identify and write things. X, X. So the X's are -7 and -7. The y's are 1 and -5. Of these ordinates, these are ordinates because a pair of them is coordinates. This is a coordinate pair, right? Let's see, I'll do this in green. See this thing in green here? That's a coordinate pair. This is an ordinate, this is an ordinate. This is an ordinate, this is an ordinate. This is a coordinate, coordinate. They together. Co means together. They are together. Okay. That's a mess. Let's clean up the mess. Now that we got that straight, let's find the ordinates that are the same. Are the x ordinates the same? Or are the y ordinates the same? It's easy to see. The x's are the same. They don't help us. Thanks a lot, x, for nothing. Well, they kind of help us, but anyway, we're not using those. We're going to use the ones that are different. Now, what do you do with these? It depends. Are they in the same quadrant? Or are they in different quadrants? Well, how would you know without having to graph it? Without having to graph it, I'll show you a little trick. Por example, let's look at these coordinates in this grid here. Let's take these two first of all. 3, 1, and 5, 1. And first step is identify which of the x's, which are the y's. Next step, which ones are the same? The x's are 3 and 5, while the y's are 1 and 1. The 1's are the same, so we're not using those. Those don't help us, not really. So we're going to do something with the 3 and the 5. Well, first of all, are they in the same quadrant or are they the opposite, different quadrants? Well, you can see they're in the same quadrant. Well, what do you notice about this? Check this out. They have the same sign. Now, you don't see it here, but there's really a plus sign here and a plus sign here because they're both in the first quadrant. Everything in the first quadrant has to be plus, plus. Okay. Let's duplicate. What if we were to take the next one? What if we were to do something like this? What if we took the 3, 1 and the -3, 1? No, no, no. Let's keep that 5 for balance, for the sake of balance. Yeah, because these are in different quadrants. Okay, let's take a look here. We have 5, 1. Oh, let's keep it, again, consistent for the sake of balance. We'll start with -3, 1, and then we'll take the 5, 1. That'll be the same. This coordinate here will match this one, but this one's slightly different, right? Okay, let's take a look. X's and Y's. These are the Y's. I just picked that color, that's why I did it first. X's. And let's clean up this stuff. It's not so messy. So the X's are -3 and 5, where the Y's are still 1. So they're the same. That's not going to help us. Now, are these in the same quadrant or different quadrants? How would you know if you didn't have the graph? You can see they're in different quadrants, but how would you know? Because this is a negative and this is a positive. Yeah, this is a negative and this is a positive. They didn't write positive, but it's a positive. There you go. That's how you tell if they're in different quadrants, same quadrants. So here's a little way to remember. Same sign, like plus, plus, or negative, negative. Same quadrant. Subtract. You'll subtract them. You will if they're in the same. If they're in different signs, like plus and minus, or minus and plus. They would be different quadrants. You will add like a toad, and it goes ribbit. That's a TT sound, but a ribbit toad. What if it's a ribbit toad? The important thing is D, okay? So let's just pretend like he makes a D sound. D, 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 D. Well, we know this makes an S. Look, it's even the shape of an S. Isn't that I just can't get over that. Let me just highlight that and with a nice big jumpy yellow. Well, that's red. We can make a yellow. I think yellow's going to pop more on this one. Yellow, yellow, please. Big yellow. Here we go. Look at that. Wham! Subtract. He says subtract. Let's go back to our problem and see what we have. If we didn't have a graph, how would we know where these are? Look at the signs in front. Here's a negative, and I don't see a sign here. There's no sign. That would be a positive then. If it doesn't say anything, it's a positive. So different. Is that a toad or is that a snake? That's a toad. And what do we do with toads? We add it. We're going to add them. So we're going to add 1 plus 5. 1 plus 5 is 6. That's the answer. If you don't believe me, let's graph it and find out. Let's do negative 7, 1 first. So remember, I always like to use red for my x's and blue for my y's. Let's start with this point, negative 7, 1. So we're going to go on the red, negative 7. 1, 2, 3, 4, 5, 6, 7. So we go over to the left. Then we're going to go up 1. Here's the blue. The blue matches right here, 1. So there's negative 7 and 1. Okay, okay, okay. Now let's find negative 7, negative 5. Negative 7 again, 1, 2, 3, 4, 5, 6, 7 on the red. Let's do negative 5. Now we're going down. 1, 2, 3, 4, 5. So this is negative 7 and 5. Okay. Now how far apart are they? You can just look right here. Let's count. Here's 1, 2, 3, 4, 5, 6. Oh, and that's what I said. But this, how does that work? How do you know? Oh, because watch what you do. You probably already caught on to this, right? What's the 5 and what's the 6? Here's where 5 is. See, this is a distance of 5. 5 units, right? 1, 2, 3, 4, 5. That's where this 5 comes from. So we take that 5 and we add it to this 1. That's where that 1 comes from. Oh, by the way, I forgot this is a negative 5. I didn't put that in there. That's important. But we're just taking the absolute value of that. Yeah, remember that? Absolute value equals 5 because distances are always positive and absolute values are positive because they are a measurement of distances.